that wants in there? Herb? That look good? Everybody happy? Everybody good? Oh, one second. Stuff there. Okay, let me make sure these guys are ready to roll. It's if I were giving you suggestions about tomorrow's ordeal, I suppose I would jot down that. I would certainly jot down that. I would jot down that. The graph of a quadratic, I can't remember what I told you couldn't do yesterday. If it's a quadratic, if it has an x squared in it, the graph is going to be what? Parabola. If it's a negative x squared, it's going to be upside down parabola. If it's a square root function, it's going to be that little switch that looks like that. If it's a negative square root function, it is swish going, that wouldn't be it, it'd be more like this. Swish going like that. If it is a, this is so small. If it is a absolute value, it's going to be a V. If it's a negative absolute value, it's upside down V. And we only have the positive x cubed one, which is, those certainly need to be the ones that you know. Stop me if you don't catch that. Those are just the different parent functions. Now, you're going to have to figure out where the starting points of those are, but that's at least going to get you the right shape. Halfway there we are. Now, those of you that had questions. Like I said, I distinctly remember last time, these were the problems that almost everybody got all the other stuff right except they did poorly. It was on this sort of stuff. So you're looking at this sort of stuff, Cameron Atkins. 1920. I can do 1920. The problem is you have to have the answers right for problem 15 and for 12 to get 19 and 20 right. All right. Problem number 15 asks for a domain and a range. So let's go to problem. Let's make sure number 15 is done right first. Is that on this page? Problem number 15, a couple of you asked me questions on this the other day. First of all, that is a linear equation. It's going to be a line. What type of linear equation? What form is it in? Standard form. And you solve standard forms ones by finding where it crosses the x-axis, that's called the x-intercept, and where it crosses the y-axis. To find out where it crosses the x-axis, you cross off the y and solve that equation. If 2x equals -1, if 2x equals -1, what does x equal? Get rid of the 2 in front of the x, you divide by 2, you divide by 2. X equals -1/2. Not pretty, but you can do it. It's between 0 and -1. -1/2 is right there. To find the y-intercept, you put 0 in for x. What did that say? Is it just a normal y up there? If you put 0 in for x, what is y? Y is -1. Y is -1. There is your 2 dots that are going to form your line. And then Cameron's question was, what is the domain and what is the range? What is the domain? The domain is how far left and right it goes. How far this way does that line go? How far that way does that line go? Well, these arrows tell you what's going to happen. and it goes forever to the left, and it goes forever to the right. So the domain is all real numbers. It's everything. Okay. Remember, x, I guess x equals all real numbers is the way we write it. If you're writing it in an interval notation, what would you do? Negative infinity to positive infinity. Either one of those is acceptable. The range, for those of you, is how far up and how far down it goes. Well, because the arrows again go both directions all the way, it goes forever up and forever down. Y is also all real numbers. Or it is also negative infinity to positive infinity. And what was it, 19? What were the graph of 15 and 12? 15 and what? 12. 12! So we got to do 12. 11, 12. Right off the bat, you look at this and you say, what type of an equation is that? It is a quadratic. It's an x squared. What type of shape are you going to get when you graph it? Upside down or right side up? A U or an umbrella? It's going to be a U because this is a positive. It's going to look like this. You just have to figure out where that's going to be. What's beyond fair first step in figuring out where your parabola goes? You have to find the axis of symmetry. And the axis of symmetry is found by what equation? Negative b over 2a, right? I suppose I should have, step 1/2 was to identify what your axis is. Or something wrong?
Should we do that one? The specific one? Because usually it's like
When can I do it on the specific one?
usually
There's usually a third one over there, but it'd be plus 0.
no, but usually
F of x and y equals are the same thing. Don't let that ever throw you off. The function of x and y basically mean the same thing. Okay? So you need to write down, define your letters. A is 2, correct? B is 4, and C is 0. The number in front of the x, the number in front of the x squared, the number in front of the x, the last thing. So you find the axis of symmetry by plugging those into whatever this is here. Negative b over 2a. B is 4, a is 2. So you end up with a negative 4 over 4, which is a negative 1. That is your axis of symmetry. So at where x is negative 1, you put a nice little dash line. That your parabola is going to be centered about such a line. After you find that, Ryan Connor,
You put that in for x.
okay, you now need to find what we call the max or the min. Well, if it's this shaped parabola, it's the lowest point, it's the min. You need to find, or we call it the vertex, whatever you want to do, by putting in what you got from step number 1. With your x value, you're going to have to make a table at some point here of x and y values. You might need a couple. I put negative 1 in for x because I want to know where on this line is the lowest point this parabola is going to be. Again, it takes a little bit of work. 2 times x squared plus 4 times x, putting negative 1 into that. Here's where you got to take a little bit of time. Negative 1 squared is positive 1. 1 times 2 is 2. 4 times negative 1 is minus 4. 2 minus 4 is negative 2. So here, where x is negative 1 and y is negative 2, that is the bottom of my parabola. Where it bottoms out. Okay. The next one you always want to put in there, is, if possible, is put 0 in for x. That's the y-intercept. If you put 0 in for x, everything goes away here. And you're left with 0. So you know at point 0, 0, the origin, there's a point. Once you get 1 point on one side of the axis, you put one exactly the same distance on the other side. Now I've got this part of my parabola figured out. And you technically really, even though I probably would make you should figure out one more if you could. I would put 1 into my equation and see what I get. 2 times 1 squared plus 4 times 1. What is that? 2 plus 4, then you get 6. So at 1, it goes all the way up to 6. 2 over, and there's your other point. Realistically, you should have some fairly short skyway there. And then, Cameron, the whole reason of doing this was so that we could state the domain and the range of it. This one is not infinity for both because it doesn't go forever down. It does go forever left and right because this will just keep getting wider and wider forever and ever. So the domain, the left-right part is x is all real numbers or infinity to infinity. The range, however, does have a starting point. Where's its starting point? At -2. So y has to be greater than, because it goes up, or equal to -2. If you were doing that in interval notation, how would that look like? Well, it would start at -2, and if you remember right, it's a bracket that does equal that, to positive infinity. Which is a parenthesis because it doesn't, you can't equal that. Happy, Claire?
Would you do that for
I would love to do them all. Yeah, and I don't get, the x cubes are the easiest of all. Okay, because I gave you, I mean, there's a whole bunch of other things that could be in that, but it's only gonna be the x cubed plus a number. This number there is where it crosses the y-axis, crosses at +2. Is your 18 different than my 18? No. Alright, and it's the x cubed function parent thing, it just does this. Always that shape. If it was -5, it would be down here. If it was -2, it would be there, just crossing it. Did I do something wrong? Is it the same as on yours?
I don't
Again, I'm more worried about the first 8 problems than I am so much about these. Most of these kind of have some sort of a handle there set up. Strixel.
Could you explain to me how to do that one since I wasn't here for it?
This one?
Yeah.
That's all there is to what I just showed you is that. If you see an x cubed, Caitlin, it is going to be that shape. Just keep practicing drawing that shape. Okay? And it is whatever this number is over here. If I was doing x cubed minus 3, that number is the y-intercept. It's where it crosses the y-axis. X cubed minus 3 means that minus 3, there's a dot, and you are going to do this shape right there. It's this same. Okay, if it was -6, it's that same shape there, which is pretty close. It is this identical shape, it just moves. It is just this. It's that shape. I guess I missed it. Right? There's nothing more to explain about it. If you see an x cubed, if you see an x cubed, my thing is here, x cubed, you give me a number after x cubed. 4 plus 4. That means on the y-axis at +4 is going to be this same shape. It is this shape. And no matter what the number is, it's just going to move up and down the y-axis depending on what it is. Okay, some of you I saw on some of your stuff on the quiz moved it this way and this way. It will not go left or right. It will go only up and down on that axis. No. Yes. Got that? Your y cube's not going to end up over here. All the rest of them may, but the y cube won't because I didn't give you those. Alex?
Number 5.
What was number 5? I'd love to do number 5. Compound inequality, the only problem is you need to solve it for the letter A. The nice thing is the A is positive, so you don't have to worry about changing any signs. These signs are gonna look exactly as they are. How do you solve it? How do you get the letter A by itself? You need to divide by 5. And the thing you have to remember with compound inequalities is that whatever you do to the left side, you have to also do to the right side. So I need to divide all things by 5. Negative 10 divided by 5 is negative 2. Sign stays the same. Negative 25 divided by 5 is negative 5. Sign stays the same. And there are all of your negative 2. It is an open circle, not colored in because there's no equal line. 2 negative 5. We have that backwards. 5 negative 2 is greater than this. I was going to say it is all flipped around, isn't it? But it's still the same. It goes to negative 5. Colored in. Those are compound ones, so it's probably facing the wrong direction. You can rotate it about its little axis here to be the same thing, negative 5, and the sign. Is that the answer? Logan?
You do number 3.
Love. First of all, when I look at these, I don't worry about compound inequalities because I don't think they're going to give you negative A's, so that things all switch around. Maybe they will. When I look at this, I ask myself, is my letter negative? No, if it's not, then this sign is not going to change. You are going to end up with a greater than or equal to sign in the end. And you just have to do it, pretend like it's a regular equation. If this were a regular equals equation, what would be the first thing that you would do? Brian?
Add 5.
Right, you get rid of the addition, subtraction stuff first. Add 5 to both sides, add 5 to both sides. You end up with a 3. And over 3 is greater than or equal to 3. Now to get rid of that, this is a division. Opposite of division is multiplication. Multiply both sides by 3. That goes away. The left of n is greater than or equal to 9. So here at 9, it's greater than or equal to. Greater than shoots off this direction. I really should look at the test because I remember there being some. There are more. I believe on the test there are a couple where your letter is negative. I would definitely jot that down to myself. If it's negative, the sign is going to switch. Definitely. See, that's why people got it wrong because it didn't happen a lot. Like this one here. Looking at this one right here. This is an OR one. OR ones just get solved separately. If 4m is less than or equal to 0, you solve that by, Madison Wilman, dividing by 4. Can I divide 0 by 4, Madison? Yeah, 0 divided by 4 is 0. I can't take 4 divided by 0, but I can divide 0 by 4. So m is less than or equal to 0. Less than or equal to 0. This one here, right off the bat, the bells and the whistle start going off in my head that my m is negative, which means in the end my sign is going to change to its opposite direction. Because when I divide by a negative 4, this sign has to change to its opposite. You know, negative 16 divided by negative 4 is a positive 4. So there's my positive 4 equal to that equation. Okay, Ron? Absolutely. I will do it on a whole different piece of paper. The first one was 4m was what? Less than or equal to 0? Was it negative 4? No, it was positive 4.
Yeah.
And the other one was negative 4m is less than or equal to negative 16?
Yep.
Alright, how about, does this one give you trouble? How do I solve this? Cabran, if I had the equation 4m equals 0, what's my answer? 4 times what number is 0? 4 times what number is 0? Multiplication tables. 4 times what number? 4 times 1 is 4. 4 times 2 is 8. 4 times what number is 0? Anybody? 0. 4 times 0 is 0.
But it doesn't.
Just like 0, again, get rid of this by dividing by 4, Cabron. 0 divided by 4 is 0. I guarantee you did that probably in whatever, 3rd, 4th, 5th grade. Okay? You can divide by 0, but I can divide 0 by 4. I can't do it the other way around, but I can do this. So m is less than or equal to 0. This one over here, here is where again, if this thing is negative, if my letter is negative, I need to make it positive with inequalities. And if that's the case, the sign is going to change. Because anytime you multiply or divide by a negative, you've changed this to its opposite. You need to change this to its opposite. For negative 4 divided by negative 4 is a positive m. Negative 16 divided by negative 4 is a positive 4. So those are my whatever. Positive 4 getting bigger because it's greater than 0. Yeah, so it's smaller. Does that make help any bit more?
One that's just happened.
Alec?
Can you explain the concept of 7 and 8?
I can't if I can figure out what 7 and 8 is. Got these? 7 and 8 are just, you have the inequality, you just have to write what, you have the finish, you need to figure out what the beginning thing is. And it's pretty simple because you can always put an X, it doesn't matter what letter, and whatever number has the circle is going to go over here. You just need to figure out what inequality sign is going to go in the middle. Are the numbers greater than -6, less than -6, are they equal to -6? Open circle is not equal. All the numbers are bigger than -6. Same thing with problem number 8. You're going to have the X, you're going to have the 5. Are the numbers greater than 5, less than 5? Greater than. Are they equal to? No. X is greater than 5. So what I got for you, Watson? Willman. 4. Absolutely. First of all, Madison, 3b plus 5 greater than or equal to 2. Is my sign going to change or is it going to stay greater than? Is the letter negative or positive? It's going to stay. Okay? That's the key. You look at right away. If that letter's negative, if the letter's negative or if it was on the wrong side of the inequality, the sign's going to change. But I don't think you're given any of those, so you can sit there and go, okay, it's going to stay. So how do you solve this if it was an equation, Madison? How do I get rid of this 5? Subtract 5. I subtract 5, I get a -3. If 3b is greater than or equal to that, how do I get rid of the 3? Divide by 3, divide by 3, so whatever that was. V is going to be greater than or equal to -1. -1 greater than or equal to goes this way. I hope that was right, was it? Did you say no? Is that the answer? Boy, for the USA winning yesterday, you're sure not very happy about this whole thing. I can't believe you didn't watch the whole thing. At what point did you stop?
I think right after they were done, like, going down the back.
Again?
Yeah.
Again. That's the best part, right?
12, no, 11.
12 or 11?
No, just 11.
Did I do 12 or 11? What is this? 12. 11. Ah! Here you go, thought process again. It's a quadratic, it is an x squared. Maybe we can pretend this is f of x, it's the same as y, it's the same exact concept deal there. What is my shape going to be, David Swenson? Yes, an umbrella. Want to go like that. Alright, so the first step again is to define what your A, B, and C is, although your C doesn't really matter so much. C is always going to be your y-intercept, but A is what, David? -1. B is what, Maggie? -2, and C is 1. So I definitely would be having my notes, the axis of symmetry is -b over 2a. You want to know where that line is that whole thing centers about. I would take my time with this and keep my negatives and my positives straight. A is -1, B is -2. -2 is a +2 over 2 times -1 is a -2, giving me an axis of symmetry at x is -1. -1. Which is good because it actually falls somewhere in the middle of the graph they gave me. Hint, hint, helpful. Now the next thing you have to do is take your -1, you're going to jot down the table of x and y values because you need to plot at least 2 more points just to give you well 3 actually. Well actually 4. Well 5, but they're really easy to get there. You put -1 into your equation, negative x squared minus, and this is where people go wrong, not taking their time and getting this all nicely done. -1 for x squared, -1 for 2x. You have to do exponents first. Negative times a negative is a +1, and then there's a negative out front of that, so this ends up being -1. -2 times -1 is +2, and then you have that +1 there. So you end up with a +2. -1 plus 2 is 1, 1 plus 1 is 2. So here at 2, which makes sense again because it falls nicely on our graph, that is my vertex, my maximum value. Next thing I'd always do is put 0 in, which ends up being the letter C. The y-intercept here is at 1. 1 that way, 1 this way. I've got my point of my little parabola here. I need to figure out one more. I again would probably pick 1 because it's easy to deal with a -3. If I put 1 into my equation, and have room to put 1 in my equation, let's do it where? Oh, let's do it right here. -1 squared minus 2 times 1 plus 1. 1 times 1 is 1. There's a negative out front, so that's a -1. -2 times 1 is -2 plus 1, -3 plus 1 is a -2. Here's my -2. And again, to be good mathematical students, you should put a little arrows. It goes further that way. Everybody's comfortable with where the vertex of absolute values and all that other stuff, how to find the right point, because I still see people making that mistake. Please make sure you understand when you are given, where are they? Are there no problems? Where's my x squareds or my, lay down here. Please make sure when you see this, first of all, the shape of that is the Nike swish. Is it negative? No, so it's going to be up like this. You just need to find where does this point go. Where does that point go? Well, you look at this number underneath the radical sign, the number under the radical sign, and you have to think opposite. If it's a -3, that means you actually go to the right 3 places. +2, this is the up and down number, and it's the way it goes. It goes up 2. Over 3, up 2, and there is your little Nike swishy thing. Was there no absolute value ones in here? Or are they on the next page, or where'd they go? What did I miss? Nobody? They were on the first page? And really, it's the same thing that holds true for this. You know absolute value is always this little thing like this, unless it's negative, it's upside down. Don't remember if there are down or not. The number inside that is the left or right number, but it goes backwards instead of, it's opposite, so it goes left 1 and down 4. 1, 2, 3, 4. That's all you need to plot because you know it's going to go off like this and like this. Nothing more needs to be plotted there. This one here, not left 4 but right 4, up 3. 1, 2, 3. And there again is. Smile. Some of you could not look more disinterested if I asked you to. That's okay. I can only do what I can do. Short of moonwalking. Oh, speaking of walking on the moon, what year did that happen?
79.
69.
60.
President Kennedy promised before the end of that decade they would walk on the moon, so they had to get it done. Fine.
I was wondering if we're switching classes today or if we'll be able to watch Miracle for a little bit.
Yeah, we're gonna watch, we'll have Miracle done before you go to lunch.
Cool.
It's a somewhat small miracle. You are going wherever you went last yesterday after lunch. What's that? Yeah. Nobody else, anything on this? I will email it to your parents, so if you wanna watch it over and over and over again.
And hear my comments and
That's the reason why I ask questions, is so we can get on the meeting.
I'm
No, don't do